Uh, Today title is combustion S engine, which is gasoline engine. We'll see. So we'll go to today topic called content of combustion gasoline engine. These are the topics that is there where your course man handout. So you'll be seeing the essential feature of process of the combustion. Combustion is going to take place, and she also see some of the thermodynamic analysis of the SA engine. So we have different parameters which is affecting the combustion in its engine, which is the flame and also the speed, flame speed, and we will see the cyclic variation in combustion, partial burning and misfire. Partial burning means it's not completely burned, it's partial. And misfiring, as the name indicates itself, we can understand it's misfire. And we will see the ignition process, and we will see what is the normal combustion, what is the normal combustion. Okay? And we will see the knocking fundamentals and its effect on engine performance. So it's a big topic. Uh, Maybe I will take today as well as even Wednesday to complete this subject on the topic called only S engine I will cover. And because I'm going to do some overview about the question also, it may take some time. So better, and again, even though the complete syllabus is not there for semester, so we will cover what is required. Okay. Irrespective of SA engine or C engine, okay, the combustion is nothing but it's not only applicable to SA, it is also applicable to CA also. Since we are talking about SA engine, I have mentioned as combustion SA engine alone. Okay, irrespective of SA or CA engine, okay, the combustion is all about the reaction between the fuel. Okay, the fuel can be a gasoline or a diesel, and the fuel is getting mixed with the air. The air contains oxygen, nitrogen, and other trace gases. So now oxygen is one of the element in the air. So when oxygen and fuel is getting mixed, you get what you get. You get uh, combustion. Okay, combustion is nothing but the heat energy. Okay, and that heat you're going to get as the form of gas. It comes out as exhaust gas. Okay, so here you have the triangle. Okay, so one side of the triangle is oxygen, another side is fuel. Okay, then once an oxygen fuel gets mixed, you get the combustion reaction is the form of heat. So when all these three are together, you get the fire. And what is output of the fire? Output of the fire is nothing but gas. Okay, the flame, whatever you can call. Okay, that comes out as exhaust gas to the atmosphere. So if in case if the air and fuel mixture is not going to get properly mixed, then what happened is uh, what are the emissions, whatever we have seen, hydrocarbon, carbon monoxide, nitrogen oxide. So when it is coming to the exhaust, it will be on the higher side. And again, we need to use catalytic converter to eliminate the combustion, means to eliminate the emission in the case of SA engine. In the case of CA engine, we use all after treatment. We have seen all after treatment. We need to use DOC, EPF, and SER or LFT to eliminate carbon monoxide, hydrocarbon, particulate matter. See, particulate matter is also called as carbon subparticle. And you need to use SER, is nothing but cyclic catalytic reaction, and NOx, LNT, you call it LNT to eliminate NOx. Okay, so this is the combustion in SA engine. So we have seen the definition of ICE engine. Okay, as per the law of conservation of energy, which says that energy can neither be created nor be destroyed, It can be transformed from one form of energy to another form of energy. This you would have studied in the fundamentals of even the physics or um, some of your very long definitions, okay, like law of conservation of energy. It states that energy can neither be created nor be destroyed, but it can be transformed from one form of energy to another form of energy. Even in engine also, energy takes place in various forms. Here you have gasoline or a diesel, which is having the chemical energy in it. Okay, when this chemical energy, when it is reacting with the oxygen, you get the heat. So heat is nothing but a thermal energy. Okay, so chemical energy is getting converted to thermal energy, and then after thermal energy, what happens is shifts and moves up and down. It is nothing but the work which is been done, and which is nothing but a mechanical energy. You are going to get the mechanical energy out of it. Uh, and so here the transformation of energy from chemical to thermal, thermal to the mechanical work. Okay, so finally you're going to get the power. It's nothing but the mechanical power what you're going to get out of it. Okay, and even even some of the energy can be also be used uh, in case if you're going to use. There are some other technologies where you can use the waste energy or the excess energy to run your the electrical things also. Even in the case of what we have in the case of regenerative braking. Okay, so the mechanical work, the mechanical energy is being converted to electric energy. Okay, in the case of regenerative braking, if you have, and no, it's okay. But as far as the engine is concerned, we normally going to deal only with the three type of energy: chemical energy, thermal energy, and also mechanical energy. This is the it is out of the topic now, or scope now at this point of time. Okay, so here the chemical energy is transformed into the heat energy or the thermal energy. So here they mentioned as the light energy uh, and also the thermal energy. So here the heat is something in the high form of the energy. Okay, so the radiant is static, but uh, initially initially what we get? Initially you get a flame or a spark. Spark is a light. Okay, it's a light. Okay, whereas when it is coming as a fire, it is something. The, the, the million formation of of the light. So you can say what the light energy is nothing but a small spark or small fire, and the millions of fire you get what you get is the heat. Okay, so you have a lot of small radiant energy in it. Okay, the fire is having energy. Okay, so when you're going in depth, about the combustion, so it is all about how you're treating the mixture of oxygen and the fuel. That is where combustion comes in there. So I have also uploaded some 290 pages research papers to your importers. So it is really a very good document. Maybe you can also have it for your reference, though it is not important for exam point of view, but a lot of advancement, whatever has happened related to combustion, it gives a complete picture. But and again, that is not a world, that is not a new document also. Those research happened almost 9 to 10 years back, but still, but nowadays still a lot of advancement is happening. But it will give an overview of how it is happening in the real industry market or in many OEMs. So there are a lot of case studies, a lot of papers have been given in that research paper, which includes four wheeler, even tractor, and some of the commercial of heavy vehicle also they given a lot of research into the combustion. So you can have a look over it. So maybe you can check what is applicable to your company. You can have it. Uh, as per the dictionary of Oxford, the combustion is nothing but the process of burning something. Okay, So I told you the burning will happen when the fuel and the oxygen gets mixed. And again, oxygen will, you cannot have the pure oxygen because oxygen will also have the air will also have oxygen plus nitrogen. And there are some, there are even some of the researches are going on. Even even instead of reacting the air into the fuel, some research are going on to have the reaction only between oxygen and the fuel. But what happens is directly mixing the oxygen with the fuel. Sometimes it may lead to some uh, the combustion which will be sometimes abnormal. Okay, sometimes because it will react immediately. Oxygen is reacting to fuel will react immediately. Whereas if it is having the nitrogen in it, we will try to have the proper combustion. Okay, so even some of the but at the same time, you need to see what is the amount of oxygen which is required to mix along with fuel. So there is a possibility if you're going for high level of oxygen, then it may lead to the complete stop of the engine as well sometimes. And again, it may lead to some safety issues also. Okay. So that's why it's very important. We have a air fuel mixer. We allow the proper amount of air considering the ECU loop feedback. But same thing can also be applied to the oxygen content also, like how the throttle valve is allowing air. But at the same time, you see here when you're allowing the oxygen, if in case the valve similar to throttle valve, what will allow the oxygen, it is going to be higher, and it may lead to some mishap or something like that. So that's why, even though there are a lot of research are going on, but it is not coming to separate the oxygen from the air and to have that. Even that is also a good method, but again, when you're eliminating the nitrogen, what happens is there is also a possibility that you can have the advantage. You can also have the advantage of eliminating the NOx also. Okay, so NOx because nitrogen is there uh, in the air, and this gets oxidized. During the oxidation, what happens? So nitrogen is going to get converted to nitrogen oxide and nitrogen dioxide or nitrogen dioxide, NOx basically. X can be anything, NO2, NO3 or the case. Okay, or even NO also. So in this way, so what happens is you can eliminate the nitrogen oxide because N2 is also going to react with oxygen. Even there will be oxidation process which may happen. So by the way, if you have the pure oxygen alone instead of nitrogen, there are some possibilities of advantages as well as disadvantages. But again, we need to because again there are also risks there. Okay, I'm saying that any researchers are in the research stage only; it is not coming into implementation. Maybe you can have some of the literature survey on this topic also. It is quite interesting how the pure oxygen alone will help for avoiding the emission at the same time improving the efficiency. It is possible, but at the same time the quantity because it will the configuration of the engine is varying from company to company, and again accordingly the quantity of the oxygen content which is required for a particular configuration will also vary. Uh, but again, you need to see whether it should be proven one. Then only it can be possible. To make it prove, it is like hydrogen now. It is like hydrogen. How hydrogen is not coming into the real commercial market, even though everything is in research stage, and because you need to have the proper the safety aspects also. Okay, even though hydrogen is going to be good alternate fuel where you can have zero emission at the same time you have high energy density at the same time you have a lot of other features. Okay, but storing the hydrogen, compressing the hydrogen, and even This can be applicable for a cryogenic application where the temperature can be even minus 20 degree also. But even it's good actually. Hydrogen is also a good options. But again, the safety perspective when it comes there, even that is the one drawback that hydrogen is having. Um, okay, we are slightly deviating the topic, but this combustion is quite interesting actually. So it's basically chemistry basically. So when it comes to thermodynamics, so I told you are going to get the energy out of it, which is first you will get chemical energy, and then you get the thermal because of the heat. Okay, and finally you are going to get the mechanical work. Mechanical work is nothing but the power what you are going to get from the engine. Mechanical work is nothing but work done by the mechanical components like crankshaft, camshaft, and all these are going to finally give you the output, the engine output, which is the form of power. We also defined the power of the engine is basically horsepower, HP we call. I also compared what is the horsepower meaning. Uh, so it is like a muscle power of the human body, horsepower is there for a engine. And I also told you the other unit of horsepower is kilowatt. You can also convert the horsepower to kilowatt, and accordingly you need to define the power of the engine. And the unit of and the power is equal to 2 pi NT by 6 to 1. We have seen all these things in the basic class. So now we will see the process of a combustion. I also told you this is a combustion. Yes. And you see, this is the chemical formula for a gasoline engine, for a gasoline fuel, C8H18, which means it is having the carbon content and also hydrogen content. Hydrogen and the carbon in the fuel, it's going to get mixed with oxygen. Okay. So I told you fuel will get mixed with oxygen. So now what the fuel is containing? Fuel is having hydrogen plus carbon. Okay. And when it is going to react with oxygen, it liberates the heat energy. I told you the heat energy is from the chemical energy you are going to get the heat energy. And from that, what you're going to get? It will also increase the temperature of the gases also. Okay. Yes, you are going to get finally the exhaust gas. Okay. The temperature of the exhaust gas, the gas which is emitting out of the combustion is going to get increased according to the combination of the fuel plus oxygen. And higher the fuel and higher the oxygen, depends again. The temperature can be high or extra high or medium high, low high. You can categorize this temperature, increase in temperature in many categories. But there will be increase in temperature, but the temperature can be low increment high, or medium increment high, or high increment high, or extra high, whatever you can categorize. Okay. Okay, this is the formula what I told, C8H18, and when it is going to react with the oxygen, I told you here it is going to get mixed. Fuel is going to get mixed with oxygen. So you are going to get this reaction, which is nothing but carbon dioxide and H2O. H2O is harmless. Okay, and you're going to get this CO2 is there. Okay, and again when it is, you also have the nitrogen. Okay, it's not only the oxygen. You also have the nitrogen, and when you get, again you are going to get carbon monoxide, nitrogen oxide, and water. This nitrogen oxide is again harmless, sorry, harmful. It's also harmful. I told you when you are eliminating the nitrogen from the air, you get only oxygen, which means you can eliminate this. Again, I told you this, but there is a possibility that it may lead to abnormal combustion. Okay, because when fire is, see, even you can have the fire and safety, whatever the people says, when fire is there, you should avoid the air. Sorry, when yeah, that they normally say, because it will add additional combustion reaction to take place into that. That's what most of the industrial fire and safety people they give training. When they are giving training, they use it a lot of these things. And you look at this now. Instead of air, if you give oxygen, what happens is still it will be the fire or whatever the things. That is where the safety comes into picture. Same thing applicable here also. Okay, one thing is if you are adding the nitrogen, you get nitrogen oxide. When you are eliminating the nitrogen into the induction, if you are having only pure oxygen, then it may lead to the safety issue. But beyond that, if you have correct the required quantity, you need to fine tune that. If you make sure that a particular oxygen alone you're going to react with the fuel, then it will be a very good thing. But arriving the correct proportion is something a challenging task. Okay, but it is possible. But again, I told you, you also have different configuration which will vary from company to company. Even the same company will have different power output of the engine, this different engine group or engine category. Okay, but there will be some challenges out there. But again, what according to me, what it is, research is going to be like a hydrogen. Like hydrogen is also good, but it is not coming there because of safety. But it is very good. It is also like a green kind of fuel where you don't get any emission out of hydrogen. You also have high energy density. Even that is also good. So this is how the real situation. Okay, when it comes to the diesel, the formula is C14H30. When it comes to a gasoline, it is C8H8. When it is diesel, you are going to get high amount of carbon and high amount of hydrogen. Okay, yeah. Then accordingly, the NOx what you're going to get, okay, is also going to be higher. Okay, this NOx can be eliminated with the help of the catalytic converter in the case of CI engine. Sorry, in the case of HI engine, where the three-way catalytic catalyst will convert CO to CO2. Okay, and C to H2O and NOx to nitrogen. And in the case of the diesel, you don't have the catalytic converter, but you have the SCR. But again, SCR is quite complicated thing. And you can also use EGR, exhaust gas recirculation, where it will diffuse the oxygen content in the air and it will reduce the peak temperature. When it reduces the peak temperature, what happens is your NOx gets reduced. Okay. And you can use LNT Linux stuff also you have seen. Okay, this is the combustion process. We have seen this in the last slide also. Formula is C8H18. When it is reacting with oxygen, you're going to have H2O plus CO2 plus you're going to get the energy out of it. That is very much important. Okay, when fuel is reacting with oxygen, what is important is what the energy you're going to get. That is important. These are the byproduct. Okay, the water, CO2 are byproducts. And what important is how much percentage of energy you're going to get. That is very much important. But again, with respect to the percentage of energy what you're going to get, you also need to see the byproduct. It should also be harmless. Okay, the water is harmless, but this will increase the greenhouse effect problem. Okay, it will increase the environmental issue. So you need to reduce this as well. Okay, that is where the injection strategies, combustion strategies, and also the after treatment or the catalytic converter comes in. Okay, this is the as far as any chemical reactions is concerned, it is having the reactants plus products. So reactants is nothing but we have seen the triangle in which oxygen plus fuel is there. Okay, in this becomes as a reactant. The product is what you're going to get out of it. You're going to get the energy, which is nothing but a heat. The heat is you're going to have the temperature in the presence of the heat energy into it. So what you're going to get? You're going to get the exhaust gas. The exhaust gas is nothing but a product which contains emissions as well as the byproduct. Okay, so this is the formula. So you see here, you have C8 2 C8, so it means 16 carbon atoms you have, and 36 hydrogen atoms you have, 18 into 36, and you have 50 oxygen atoms. Similarly, when it comes to product, you have 16 carbon atoms, 16 C is here, okay, 16 carbon atoms and 36 hydrogen atom. It is again 18 to 36 and 50 oxygen atom. You see how you are going to get 50 oxygen? Here is 18 plus 16 into 2, 32. You're going to get 50. So this is how you need to balance both reactants and the source products. Even we have seen a lot of chemical reaction in even exhaust gas treatment also. Okay. When you're writing this type of reactions, you need to balance it and you have to write it. Okay, coming back to the combustion mixer, where you get air fuel get mixed. In the case of SI engine, say is also called as a gasoline engine or a spark ignition engine. Mixer is said to be the homogeneous. Okay, whereas in the case of diesel, it is called a heterogeneous mixer. So what is called heterogeneous mixer? The mixer components are distributed non-uniformly. The air and fuel mixer are going to get distributed non-uniformly. Whereas in the case of homogeneous mixer, the mixer components are going to get distributed uniformly, like in the case of a SI engine or a gas. Usually, this is all about the air fuel mixer. One, you can consider either one as a fuel, another one as a air. For example, we can consider the pink color as air and fuel as this. The mixer components are distributed non-uniform. The mixer is non-uniform. You see, it is non-uniform. But in the case of gasoline engine, you see, you can get the mixer which is uniform. That's why even with the help of only the catalytic converter, you can eliminate the carbon monoxide, hydrogen oxide in the case of gasoline engine. But in the case of diesel engine, the mixer is heterogeneous. But now what happens is they are going for HCCA engine, which means a homogeneous charge compression ignition engine. So even they are going to adopt this technology into the HCA engine. They are going to have a uniform structure, so that will help for reducing the emission as well. Okay, we will see the combustion in SI engine. It's now we'll go to the topic. In any now I have mentioned that the fuel and air is going to have, and it is going to be a homogeneous mixed. Okay, whereas in the case of SI engine, it is heterogeneous. And when it is inducted into the intake valve, the cylinder, you are going to get the residual gases, and it is getting compressed. The valve timing diagram we have seen. The piston moves from TDC to BDC, where the air fuel mixer comes, and when it is moving from BDC to TDC, and it gets compressed. Okay, and you get under normal operating condition, the combustion is going to initiate. You are going to initiate the combustion towards the end of compression stroke when the piston moves from PDC to TDC. Okay, which means it is nearing to the completion of the compression stroke, which means towards the end of the compression stroke. At the time, what happens is you're going to have the combustion going to get initiated when the spark comes into picture, comes into action by discharging the electric current. And here you are going to then what happens once you get the combustion starts, initiates, you are going to get a flame. Okay, nothing but a turbulent flame. You are going to get turbulency out of it. The flame you are going to get. You see this very carefully. We have seen the valve timing diagram. The piston moves from TDC to PDC. The air fuel mixer comes in during the induction stroke. When the piston moves from BDC to TDC, which is nothing but a second stroke, or also called as a compression stroke, and when it is nearing to the completion of the compression stroke, you're going to get a spark gets ignited, and you're going to get a combustion. Means the combustion is not going to be immediate, you're going to initiate the combustion. You see here, you're going to get the combustion once the spark gets ignited, and you see here if the spark occurs too early, Okay, when a spark is going to get occurred very early, then what happens? The combustion takes place before the compression stroke is going to get completed. Okay, so here the pressure going, whatever you're going to get, pressure pressure developed, it will also oppose the piston movement. Okay, oppose means the piston is going to move from BTC to DDC. When it is opposing, what happens? The movement, the speed of the piston is going to be reduced. When the piston speed is going to get reduced, what happens is the mean speed of the piston is will be lesser. Which means when the mean piston speed of the piston is less, obviously the power what you're going to get will be lesser, or the torque what you're going to get out of that is going to be lesser. Okay, and what happens now? I will tell you the next one. If the spark is going to occur too late, too early is also problem, and even too late is also problem. When it is going to that too late, what happens? Piston would have already completed a portion of the expansion stroke. What happens after compression stroke? The third stroke is nothing but expansion stroke, where the piston moves from PDC to BDC. Okay? And again, the same issue will come. Okay, so the correct instant for the introduction of the spark is decided by the term. You underline this. I am going to underline. It's nothing but the ignition lag. It is always, that's why you have the in the ball diamond diagram you have the ignition before DC whatever 10 degree, 15 degree, what even this is same thing applicable even for a diesel also, where you call fuel FOV call fuel opening valve call. Okay, this is very quite common between SA and C engine also, but you need to have the correct instant for the introduction of the fuel or injecting or igniting. So the conditions that are necessary for a combustion are the presence of a combustible mixer. You need to have the combustible mixer. You need to look for the you need to look for initiating the combustion. You have, this is a spark plug. Okay, so you should ignite. You're going to get the electric discharge out of this. Okay, and a very important thing, that's the third one. You need to stabilize and also the propagation of flame in the combustion chamber. See, the flame should not also be, it should not be too high, it should not be too medium. So how you are going to stabilize that and how you are going to propagate the flame, the combustion chamber, even that condition is also necessary for a combustion. Okay? So because this is how the flame, you see how it is traveling. Okay, it is also going to travel with some velocity. Okay, and again with some velocity is the distance. What is the flame distance? That means it will start like higher one and it goes like high to low. Even you can see here. You see how it is going to? It is going like and it will go like this. Okay? You can see my cursor, which means it will reduce the gap with the gap from bottom to the top. And when you take from bottom to top, the overall length is also very important. And the compression dependent parameters is basically the two parameters are going to depend upon the compression. And the compression is, sorry, the compression is going to depend on that. Okay, it's not that this parameter is going to depend on the compression. Of course, the efficiency of the compression will also depend on these parameters. Okay, this compression is dependent on mostly on the two parameters. One parameter is the flame front, and next one is the flame speed. First, we will see the flame front. Okay, so the flame, I also told you this is how it is going to be. Okay, the flame. Okay, and you are going to get the boundary. This is the boundary. You are going to determine the boundary. Okay, this is the flame boundary. See, what is called a flame front? Flame front is nothing but the boundary or a front surface of the flame. This is the front surface. Okay, this is the front surface of the flame that separates the burnt charges from the unburnt one. You have burnt one and so unburnt one. What is the burnt one? Burnt one means the fuel is going to completely burn. when it is reacting with oxygen. What is unburnt one? Okay, unburnt is the one where the fuel and air is not, or oxygen is not going to get completely mixed. You have the fuel droplets, okay, still left out, still unburnt. Okay, that is called unburnt gas. Okay, when it is burnt gas, is one and unknown is unburnt gas. It is going to separate the flame front is going to, it's the boundary or the surface or the flame that separates the burnt gas from the unburnt gas. Okay, and the other parameter is the flame speed. What's the meaning of the flame speed? I told you the velocity. Okay, from here to here it travels with some velocity. The speed at which the flame front travels, that determines the flame speed. I think this topic is going to be very much interesting, but you need to have a feel of it. That is very much important. So basically, people who is good in chemistry kind of thing, they will feel more interesting towards this topic. And at the same time, I know many of you are working in this topic also, even in industry. For them, it's quite interesting, and again, even they can adopt some of the new things into their systems also, engines also. Uh, again, this dependent parameter, combustion depending parameter, or flame front and flame speed, will also determine the burning rate of the system. System here is the combustion burning rate, and that is also depending on the ignition, open-end ignition or closed. Again, you can increase the burning rate, or you can decrease the burning rate, or you can optimize the burning rate considering the design what you're going to have for a combustion chamber. So you can also go for a shallow depth chamber. You can also go for a hemispherical shaped chamber. Okay, this is the hemispherical combustion chamber. This is the hollow. So according to that, so when you're going for hemispherical one, the flame you are going to get this way. Closed end you are going to get the burning rate. When you're going for a shallow depth chamber design like this, when you're going for a design, you're going to get the burning rate when it is going to have the open end. Okay, open. That is why you have the ignition is going to be either open end or closed end. What is called open end. Okay, when you're start of the ignition called. Okay, when you're starting the ignition, and that is going to be open, and when you're closing it at the end of, it's not at the end of the period, but it's once you're going to ignite during the closed stage. But again, anyway, you're going to get a burning rate can be either higher the closed side or the open side, irrespective of that. What is important is the flame speed and flame front, that is very much important. And again, the design of the chamber, that is very much important. So where you can also ignite the fuel. You see here in the case of the shallow depth chamber, where you are going to get the burning rate at the start itself. Okay, and you see here in the case of a hemispherical chamber, you are going to get at a closed end distance nearing to the piston. Okay, this is a piston bowl. Okay, when the combustion is touching the bowl or the piston, that is where the burning rate is going to be higher. You see, this is where the burning rate is going to be higher. Whereas in the case of the shallow depth chamber, the burning rate will be higher at the start itself. That means here start here is open end. Okay. Means open water is nothing but when it is above the surface. So the above the surface is nothing but water highlighted here. So this is the difference. Okay, how the burning rate will work. How in what way you want to have. So this is the stages we have seen this many 2-3 times we have seen this. When you are igniting the fuel, you are going to get the pressure out of the combustion, and it comes to the normal stage, and it goes to dead stage. It's a dead stage, okay. And we have seen the power loss is going to get, the charger is going to get when you are advancing the ignition. And when you're over advancing, okay, this advancing ignition advance can be too early or too late, whatever it is. We have seen if it is too late or even if it is too early, in both cases you get the less power. The power is going to get lost. That's what it's pressure is going to be lost, which means the power you are going to be lesser. And if it is over advanced, what happens is the wall timing is very much important. Okay, so when you are over advancing it, this you're going to get that abnormal sound, or the pressure gets suited up on a higher level. You're going to get a knocking out of it. Knocking is the sense it's an abnormal sound where it will get because of this over advancing stage. This is quite again interesting. So air and fuel both comes during the intake stroke. So that's why it is called homogeneous mixer. Okay. And when it is going out, what happens? It is having the hydrocarbon, NOx, CO. And you can eliminate all these things with the help of what a catalytic converter. Okay. This is what we have seen also in the previous classes. So here what happens is the formation of the pollutants in the combustion chamber. So this is the combustion chamber. Okay, this is the combustion chamber. Again, the combustion chamber can be either hollow or hemispherical. Again, you can have accordingly. Okay. So now I will explain still in easy manner for you. So the burning rate, what I told in the last slide, burning rate will be higher here. At this location, the burning rate will be higher. When you're going for the hollow shape combustion, but the burning rate will be higher here when you're going for a hemispherical where it's nearing to the surface of it. So the formation of the pollutants is again can be minimized. Here it is nothing but the pollutants, okay? So the pollutant can be minimized in the combustion chamber. Like you see, this is very the key word is here is you need to control the air fuel ratio. Okay. Again the spark timing. Okay, these two again whatever you have seen in the wall timing diagram. Okay. So controlling the air fuel ratio. This is where the challenge lies also. This, so I also told you instead of air when you go with oxygen, even we are facing the problem to control the air fuel ratio itself. But when you go into oxygen, that is where still you need to get a lot of literature review, you need to get a lot of literature survey, you need to get a lot of documents to arrive at the proper value. And again, even if you arrive at the proper value, what happens is, I told you you have a lot of engine configuration. When you have a lot of engine configuration, what happens? Even when you arrive at it, it may go in something. Sometimes you'll have less oxygen. Less oxygen is okay. Okay, absolutely no problem. There will not be any safety issue. Only you will not get the combustion efficiency or the burning efficiency or the mechanical efficiency or even volumetric efficiency or the brake efficiency, what you call. It doesn't matter. Okay, even if you're not getting the efficiency, it doesn't matter because it is. but what happens when it comes to the safety issue? Okay, when the oxygen what you're going to have is more, then again it becomes a safety issue. Okay, so in both ways, will problem. Safety will affect the accident sometimes. That is most important. It may that is also the problem. Even if you go with the efficiency lesser, also problem for the company. So in both ways, it can be possible. I'm not saying it is highly impossible, but like what Dutch have in the case of hydrogen, same thing is also here. But hydrogen only problem is the safety with respect to the storage and other thing. But with respect to the emissions, what you're going to get from the hydrogen is it's absolutely going to be good. So when it comes to the catalytic converter, okay, so this is what You can reduce the carbon monoxide, hydrocarbon, and oxygen of catalytic converter in the case of SA engine. Okay, in the case of C engine, it's very difficult. Sorry, it's very different. Where you need to, it's different as well as even difficult also, because you have a lot of technologies. And again, you see this very carefully. You have rich mixture, lean mixture, and stoichiometric mixture. So this air fuel mix ratio will determine which mixture it belongs to, which category it belongs to, whether the category belongs to rich side or the category belongs to lean side, or it belongs to the correct amount of air fuel ratio or not. Accordingly, the catalytic converter efficiency can also be arrived at. So this is the effect of mixture composition. So whatever the mixture you're going to get here, okay, that will have the impact on the efficiency of the catalytic converter also. So it is not that with the help of only catalytic converter you're going to reduce the emissions, but it's also depend on the combustion. Okay, combustion is nothing but the air and fuel mixer. That is again the air and fuel mixer. What you're going to get is in the form of a ratio. Okay, and that ratio uh, is divided to three type of category. One is the rich category, lean category, and correct category. Correct category is nothing but the stoichiometric ratio. So when you're going for a rich mixer where you have high amount of fuel and less amount of oxygen or air, and when you're going for a lean mode, you have high amount of air and less amount of fuel. When you go for high correct amount of air fuel ratio, you call this equation as a correct ratio. And the efficiency of carbon monoxide and hydrocarbon, the conversion will be much more higher when the engine is running in the lean mode. See, it is the lean mode. When the engine is running in lean mode, lean mixture, that high amount of conversion in the catalytic converter, maybe 95 to 90 to 95 percentage, you get the HCO gets reduced. And when the engine is running in rich mode, where you get high fuel, less air, and the nitrogen oxide emission can be higher. Okay, the nitrogen oxide emission can be higher, which means the conversion of nitrogen oxide can be higher. So it's not that the nitrogen oxide is going to be higher. It is like you can eliminate the percentage of reduction in respect to the nitrogen oxide. 90 to 95 percentage you can eliminate, or you can reduce the nitrogen oxide. So which means the efficiency will be good. Same thing is applicable here also. So the value 14.7 is to 1 is the correct value respect to the stoichiometry. This is how the three-way catalytic converter the efficiency graph. Okay, that's why the combustion is very much important. See, why I have taken the exhaust gas emission as the second topic to many of you is, many of you might be knowing, even if it is non-mechanical background also, they may be knowing the emission point of view. So they are aware of carbon monoxide, hydrocarbon, carbon monoxide, nitrogen oxide. This is quite not new topic also. And again, what happens even if it is mechanical or non-mechanical background. So you may all will be knowing about the BS6 norms. Okay, that is the upcoming one, and in the government of India, and even the law had been there. Now, whatever the vehicle which is coming now after the April 2020 should be with BS6. So many, I can say all 100% of you know about this BS6, even though if you are from the other background. So that's the reason why I have taken that topic as second one now before this. So it is not that, but logically speaking, it is good to go with the stages first after completing injection, then combustion, then exhaust gas. But many felt for the first class after seeing the first class, but many felt that something new, something the difficulty. I could able to feel the difficulty because of some of the feedback I got from your batchmates. So they felt a lot of difficulties. That's why I gone with the easy topic, and then I'm going with some even the combustion is going to be very quite interesting. Even induction is also going to be interesting. The thing is that because of a lot of construction drawings and the methods, it may make feel that it is heavy for you. Yeah, I told you, you see, he this design I have told you how it will have the impact on the burning rate. But when you look at the non-mechanical background candidates, when they look at this, they feel it's very difficult. Okay, but it may take some time. But what is important is try to understand the concept. Then it will be easy. And similarly, when it comes to the electrical electronics, the mechanical background candidates will feel tougher, especially when they are going with motors. You also have the electric and hybrid vehicle. Maybe you may be studying that subject in the third semester, I think. So when it comes there, um, with respect to the electric motor, batteries, power controller, power electronics, motor controller, uh, the mechanical will feel difficulty about that. Okay, it is quite normal. Okay, and this is the efficiency conversion. Uh, Now we'll see the ignition limit in the case of the combustion AC engine. So the air fuel ratio, when it is going to be between 14.7 is to 1, that we call that as a stoichiometric ratio. This is going to be the stoichiometric. So left side of the stoichiometric you get the rich and right side you get the lean. So left side you get the rich and right side you get the lean. So you get the rich can be again the rich or too rich. Okay, when it go beyond this, it's a too rich, and when it goes beyond this, it's too lean. Yeah, so I'm going to categorize that into too rich, too lean, and what is the ignition limit for the hydrogen and the carbon? Hydrocarbon is nothing but it is having hydrogen. Okay, P8H18 hydrogen plus carbon. Okay, that is why it's hydrocarbon. Now you see here the limit. How I'm going to fix is I'm not going to fix the limit only for the stoichiometric. Okay, I'm not going to fix only for the stoichiometric. Even I'm also not going to fix for the too rich side or too lean side, but I'm going to find the limit between the rich side to the lean side. So this is the limit. This is the limit. Okay, that is what we call that. This is the limit for hydrocarbon again. So in the initial stage you call a carburetor engine carburetor. Okay. Then what you have is a fuel injection system, electronically controlled injection system. Okay. Uh, this is not. But you see, when you're going for the initial level, the golden base engine, okay, where you have the carburetor, you have the limit. The limit can be from. You see my cursor properly. Maybe I can go to pointer. See, this is the limit what you have for the fuel injection. Maybe electronically controlled one. When it goes to the carburetor, okay, so the rich or the lean, the bandwidth can be reduced. When you're going to reduce the bandwidth, what happens is your ignition limit is also going to be lesser. Okay? That's what it's on here. But normally, strictly speaking, the ignition limit can be put between, but it's not beyond the two rich or two lean side. Okay? And this is applicable for whatever the technologies I told, uh, electronically, electronic fuel injection, uh, and even the advanced technology, the vaporized fuel injection. Okay. But weapons technology is not there in the syllabus, but just to give an overview, I given how to improve the injection performance. I send some of the articles also. You can have a look over it in WhatsApp. Now we will see the stages of combustion in AC engine. So same, whatever it is previously, same applicable here. Okay. Okay. So before this, actually there should be some slight modification in the slides. These slides should come here. Okay. So now I will explain. Because you need to understand what is the theoretical one. This is the practical one. This is the practically it is going to happen like this. But what is the theory? Theory means uh, it is theoretically speaking how the pressure versus crank angle should be. The stages of combustion in SI engine. So this is the pressure, x-axis is the pressure, y-axis is the crank angle. So this is the we called it pressure as P, crank angle as theta. Theta is nothing but gearing. So we call this as a P theta diagram, theoretical P theta diagram. So in an ideal engine, the entire pressure rise during combustion takes place constant volume. So the SI engine is going to be constant volume, and that is nothing but at the top dead center. So when the piston moves from DTC to PDC, that is the first one, first stage, intake stroke. The next one is the compression stroke, moves from BDC to DDC. And when the piston moves from BDC to TDC, what happens is when the piston moves from BDC to TDC, the compression is going to happen. That is the first stage, the compression stage. At the end of compression, okay, you see, it is not going to happen. The ignition or the ignition is not going to start at the end of compression, right? You are going to get the ignition before the compression, which means before top dead center. But theoretically speaking, the compression at the end of the compression only means at the TDC only the compression the pressure rise will happen. So pressure rise means this is the pressure rise. Pressure rise will happen like this. Okay, so this is nothing but the combustion stage. Combustion basically the expansion stroke, what you call before expansion. Sorry, it's before expansion stroke. So the combustion will start before the expansion stroke. And strictly speaking, with respect to the wall timing diagram, we have seen that 15 degree before top dead center or 20 degree. Okay, and again the limit is there. So I'm assuming that 15 degree. Okay, so before 15 degree means before top dead center, uh, the expansion or sorry, the compression before the compression stage, you are going to ignite a fuel or inject a fuel according to the engine type. The pressure shoots up, right? The pressure shoots up. So if the pressure shoots up, it's not a linear one. See, here it is a linear, or sorry, it's a straight one. It's not going to be straight. That's why it is called theoretical. It's not a practical one. And again, what happens is after that, once during the expansion stroke, in the case of expansion stroke, the last but one, the pressure reduces. Okay, when the pressure reduces, it, and pressure versus crank angle, the pressure volume diagram, we have seen PV diagram. This is going to happen at a constant volume. So this is the volume diagram. When you take this as a volume and this is the volume and this is the pressure, the volume is going to be same at constant volume. Okay. Whereas when you take the diesel engine, it will be a constant pressure. This is very much important. However, in an actual engine, it does not happen as shown here. Okay, it will not happen like this. So how it will happen? This will happen like this. This is the stages of combustion in engine. So this same pressure crank angle. So this is the point. AB is the point. So here is the point before TDC. Okay, here it is something like close to 20 degree. Before this, the spark gets ignited. Okay, so when the spark gets ignited, what happens is you're going to have a lag. It's nothing but the ignition lag. So you cannot get the immediately. You will not get the combustion. You will not get the combustion like this immediately. So you have some lag where slowly the pressure gets increases, and once it comes to this stage, uh, the pressure shoots up. It's nothing but the compression going to be high at a higher burning rate. You can tell even in the burning rate point of view also. See, the pressure is going to be higher, which is nothing but the burning rate is also depending on the flame, the propagation of flame, and that's why the BC stage is called as flame propagation stage. And first stage is nothing but ignition lag stage. I will explain that in depth. But you can understand what are the stages. And CD is the last stage, where you will not get any burning. Okay? It's after burning. So the burning will happen here. Okay? The air field gets burned completely here. And the last here, you don't have any burning. That's the stage called as after burning. And you see, very important, quite interesting thing. The pressure shoots up from B to C. At the same time, the pressure is going to be reduced here. Okay. So under what condition it will reduce? It is reduced in the case of motoring. What is called motoring? Okay. So you're going to start the engine with the help of the fuel. Okay. You're going to have the fuel for starting the engine. Suppose if you are going for a motoring thing where you are going to cut the fuel, which means when you're going to cut the fuel, what happens is you're going to start the engine by cutting the fuel, which means there is no but initially you started the engine where you get the lag. When instead of going to the high level, you don't have the fuel, you're going to go to cut the fuel, which means your the pressure going to be lesser. Okay, so you should avoid the motoring, but even when you're measuring you should avoid the motoring, but when you're measuring the friction mean effective pressure of the engine or friction power of the engine, mostly they do in the motoring condition sometimes. Okay, and even they also take into consideration also. Okay, under motoring condition, what will be the effect? Because when you don't have the fuel, but when you don't have the fuel, and again when the moving components like piston, crankshaft, camshaft, when everything is coming to the moving condition, the friction what you're going to get or what it is going to develop in this particular motoring condition is likely going to be the worst one. So that is the reason they sometimes go with the motoring condition, friction power and friction mean effective pressure also. But practically it is not going to happen because you are not going to cut the fuel in any of the things. But this is mostly used for when for some of the measurement. But in rare cases, the engine will come up with the motoring. But still, uh, but again, you have some the power issue. Okay, when I say it's power, pressure is going to reduce. It's again coming as output power. Output is nothing but the power. Okay, what we can call this as the speed of the engine or the torque output. Okay, the power is going to be lesser. The speed and the torque is going to be lesser. It means you cannot expect the required relevant speed or the relevant power for the particular engine. So here they have mentioned the compression pressure as 8 bar. Okay, and again it's not going to be exactly at 8 bar. It will vary from engine to engine, and again all depends on the engine configuration. When the engine is in high maximum power, where this stage, the B to C stage, where at the C you get the maximum peak pressure, it is going to be 26 bar for this engine. And again, see, this peak pressure is going to be higher in the case of CA engine. Okay, it is going to be high because the stages of combustion is going to be different there. And again, you also have to see higher carbon content, higher hydrogen content. Okay, when that will suit up the temperature of diesel. Now I will go slightly in more depth stage about. We will complete only up to the stages alone today. Then we'll go I will explain much more other topics in Wednesday. But before explaining on Wednesday, first we will complete the quiz answers. Then I will explain this further topics. So you have a lot of time, but even though it is not covered in the examination point of view, but at least the stages is very much important. Okay, uh, the stages in essay engine, and you have to understand the question, and you have to in what way the question is asked. Okay, that way you need to answer. Sometimes the questions can be very indirect. You know you have all the material what to write, but you need to understand the question. Okay, if you're not understanding question, then it could be a like you may end up like how there will be some twist in the question, but how slight twist was there in the quiz, but same thing can be there because quiz is very point 0.5 or point something, but when it comes to examination, there will be some twist, but the answers will be there, but you need to know which answers you need to write. Okay, but at the same time, even you know the answer relevant to that, you need to mention as per this one. And that is where you need to slightly concentrate on with respect to the answering point of view. Okay. So now we go with the, the, the stages. So first one is A to B. A to B is the first stage called ignition lab. Uh, so here this is going to happen. So here it is going to be 20 degrees before tablet center. It is the point. A is the point of passage for the spark. Okay. And B is the point at which the beginning of pressure rise will happen. Even the pressure rise can happen A to B also, but uh, sudden pressure rise will happen after B. So the B is the starting point for starting the pressure, which is going to be higher, and C is going to be the high peak pressure. Okay, and so you're going to stage as AB is the first stage, ignition stage, propagation flame stage, and after burning stage. So this is the Ricardo software you made also what uh, some of the wave kind of thing in some of the message I have seen. So Ricardo software is also good. It has been introduced by a scientist called Sir Ricardo. He's he given the modulation for all the combustion what you are seeing in the engines. According to him, the combustion process is going to happen in three stages in the case of SA engine. So as we have seen, A to B is a spark stage, and B to C is going to be the propagation flame stage, and C to D is going to be after burning stage. So he classified. Okay, there are a lot of the software. Even this Ricardo is they have a company also Ricardo. So they are similar to the AVL. Even Ricardo also supporting engines. Even the transmissions also they are good. They are in very good competing the market to AVL. But this is like a Tesla, which is a way forward for electric vehicle. That is a way forward that what we have all the combustion at this point of time. We'll go with the explanation of ignition lag and the flame propagation stage and after burning. And with this, I will try to complete today. Then we'll go for a question answer. And if possible, I will try to cover the uh, the combustion in a SA engine, abnormal and normal combustion. So I will try to complete this five slides alone. Then I will go with the question answer session. So the first stage is nothing but the ignition lag stage, A to B. What is there is some facts which you need to understand about the ignition lag. So this ignition lag, it's nothing but there is always a time interval between the instant of spark, it is the instant of spark, and the instant where there is a noticeable rise in the pressure due to combustion. So you will not get the combustion immediately. Okay, that's what I also told you. You have some time. You need to have some time. when it is like whenever when any of the running race athletes, okay, they, the speed will not get pick up in 1 or 2 seconds. Okay, first 2 seconds are they will try to increase the speed, but the real speed will come some lag. Okay, uh, so that is same thing will happen here also. Just I'm giving you the comparison between the athletes when they start running the race. How will they go with high velocity at the initial, but they give high movement. I'm not saying that they are going to increase the speed at this stage, but they're going to increase the speed even here. But the real thing will happen only after few delay what you call. So in the case of diesel, you call this is a delay. Here you call this is a lag. But the delay and lag almost same meaning I feel. Okay, this time lag what you call is the ignition lag. Okay, so this is the time lag. Um, so again, this ignition lag is the time interval is going to happen in the process of chemical reaction during which the molecules gets heated. Okay, the molecules here is the air fuel. Okay, air is a molecule, fuel is also a molecule. It gets heated up. The self-ignition temperature gets, which means it gets ignited and produces the self-propagation nucleus of flame. So you're going to get a flame out of it. Okay, so it's all about the triangle, whatever. So, but there will be a lot of theories, um, but you need to understand only the important. They will tell in different ways. They will tell in chemical formula. They will tell in the molecules. They will also tell in atoms. Okay, um, but all this all about the triangle. So this ignition lag is going to be very small, and it lies between. This is the time. Okay, so the time is going to be very less. Maybe showing here the range between 0. Very you see how much decimal before. Again, this is going to be approximately 2 milliseconds, or it is still it's very less. Okay, millisecond is not even a second. Okay, it's very less, and this process, ignition lag process, basically it's again a chemical thing. It depends on the natural properties of the fuel. And again, you have leaded what is this gasoline thing. Okay, so again, accordingly, the property of the fuel will have vary. And again, all the fuel it can be. So now we are speaking about the gasoline. So the content of the ingredients are you have a lot of things, right? So according to the property of the fuel and even the temperature also, even the pressure, depends on different condition. Um, the ignition lag time also will vary. And you see here, the process, chemical process basically depends on the properties of the fuel, nature of the fuel, and again, with respect to the temperature and pressure in the combustion chamber. And again, the combustion chamber pressure rate and this one also depending upon the flame speed and the burning rate, and accordingly, what is the design of the combustion chamber we're going to have, and this also will have the impact on determining the ignition lag for your engine. Again, the proportions of the exhaust gas and again the rate of oxidation. Like all this will have the uh, overall impact or overall effect on the ignition lag. And the next important stage is the second one, where the real pressure you're going to get suited up from P to C, it is nothing but the flame propagation stage, where you're going to increase the velocity of the flame. Okay, when and again it goes from higher width to the narrow width. When it goes to the narrow width, you get high pressure. The pressure. This is where you got the very narrow width, and finally you get the expansion stroke. Okay, so now expansion stroke is nothing but after burning that will come in the next slide. So the B2C is nothing but the flame combustion stage, and here the flaming of the spread is going to happen throughout the combustion chamber. Okay, so throughout the combustion chamber descends up to the surface of the piston. Okay, from the surface where it started the propagation, let's see the propagation. Okay, starting point. This is the starting point of segment where this is how this the theory. Okay, whatever I told is like this, measuring between the pressure and crank up. You call this as an indicator diagram. And you see, this is very much important. During the second stage, the flame propagates practically at constant velocity. See, even the velocity, see, if it is not going with the proper constant velocity, almost velocity is going to be same. If the velocity is going to be high, there can be a problem of even knocking. Knocking in the sense, pressure, when the velocity is going to be uneven or it is going to be very high, you see here, it will come here like this, it overshoots and it gets some abnormal sound kind of thing. Okay, it may, even though it is good to increase the pressure, but it may, if you're not going with constant velocity, then it may also end up with the issue or damage of the engine sometimes. Okay, so here what is important is the heat transfer from the piston to the cylinder wall. Okay, you have the piston, and the piston moves from PDC. Sorry, we will go it again step by step process. First one is the piston moves from PDC to BDC, where air fuel comes into picture. Next is the piston moves from BDC to TDC. Before 20-degree TDC, the fuel gets ignited, spark gets ignited, and you see here what happens is once it gets ignited, you have a delay period or ignition lag period. You have ignition lag here. After ignition lag, you have the flame gets propagated. During the flame propagated means when the piston moves from TDC to PDC, for example, okay, that is where the real combustion is going to happen, or the, the, the power stroke. Okay, it is nothing but a power stroke. Here, what happens is during the flame propagation stage, it is nothing but during the power stroke. So at this point of time, you are going to get high pressure, which means the rate of heat release is also going to be high. And when the pressure is going to be high, the heat release rate is going to be high. And this heat release rate high is also going to depend on the turbulence. We have seen the swirl, turbulence, and other thing, okay, other parameters which will determine the velocity. So this rate of heat release is also going to depend on the turbulence, swirl, and also on the reaction rate. Again, also depend on the mixture composition. So, and very important thing here is the heat transfer from the piston to the cylinder wall during the flame propulsion stage is going to be low, because why it is going to be low is because only a small part of the burning mixture comes in contact with the wall. Because it's not that the burning mixture here is nothing but air and fuel. Only very few part is going to come in contact with the cylinder wall. Not that the heat transfer from the piston to the cylinder wall is going to be higher. The heat transfer is going to be higher. Whenever the heat transfer is going to be higher, what happens is um, it may lead up with some lesser thermal efficiency of the engine. Okay? Because you should not, you should have some heat. Okay, this is a very important stage where you need to retain the heat. Okay, you need to have the heat out of it. Okay, if you don't have the heat or the thermal efficiency of the engine, what you call thermal energy, so when you lose the thermal loss or the heat loss will be lesser. So we have seen a lot of losses like blow loss, bobinal loss, heat loss, time loss. Okay, and we have seen many losses, pumping loss. So the lesser the heat loss, you will get better efficiency. So if you lose the heat loss in the stages, then again your efficiency or output going to be gets impacted. So this is where it is very much important here. And the rate, how much is going to increase, is also depend on the heat release rate, okay? and this also depends on the volume of the chamber, combustion chamber, and so all this design is basically it will vary. I am not going with respect to the configuration point of view, because if this goes, then the company like Maruti, Hyundai, Tata, Mahindra, every companies will have their own configuration. I'm not going to touch on that, but here I'm going to touch only the basics or the theory behind this is basically depends on the different configuration of engine, because for the same configuration the rate of pressure release or pressure with respect to the heat release can be vary from company to company. Why? So I'm not going to have that much comparison at this stage. Just I'm going to give an overview how it will happen in general with respect to the theory point of view. So again, here the rate of pressure rise is also depending on the rate of heat release. So the last stage is nothing but after burning stage. So here this is nothing but the expansion stroke. It is nothing but the expansion stroke, and this will start after the maximum pressure is reached. And here what happens? You see, the flame here is going to be higher with higher velocity, but when it comes to C to D, the flame velocity is going to be lesser. When the flame velocity is going to be lesser, which means the pressure is going to be lesser. Okay, and the combustion rate is also going to be low because we have less speed or less velocity of the flame, and again the flame front surface is also going to be lesser. What is the flame front? Flame front is nothing but you are going to reduce or you are going to separate the burned gases with unburned gases. And the last important thing is in the case of expansion stroke, obviously there will not be any pressure rise. Because we have seen the pressure versus volume diagram, we have seen in Otto cycle, diesel cycle, where during the expansion stroke, what happens is pressure is reduced. Okay, the pressure is not going to be higher. Okay? The pressure is going to be lesser. So that's what happening here in after burning stage. Okay, we will complete this with combustion in SI engine. So you have two type of combustion. One is normal combustion and one is abnormal combustion. What is nothing but the normal combustion? When the flame travels evenly or uniformly across the combustion chamber, this happens going to travel uniformly. You see, I go to pointer. You see, it is going to have a uniform flame travel from the start to the end of the combustion chamber, which means across the combustion chamber. So the flame travels evenly or uniformly across the chamber, you get a normal combustion. Similarly, when you are going to have the combustion, just deviated from the normal behavior and resulting the loss of performance or damaging. Sometimes that's where the performance loss happen, even will also damage the engine by overshooting of the pressure. That there you get an abnormal combustion. In the case of normal combustion, you see how it will be. You get a normal burning. Okay. But when you go for a or a abnormal combustion, you get high explosion which is happening abnormally, and it may lead to the engine defect called knocking detonation called here. The case of SA engine is basically the knocking, and in the case of C engine it should be detonation, but both are like creating the damage to the engine. Little, what is the preignition? You have the abnormal combustion. It can be either because of preignition or because of the knocking. So what is called preignition? Preignition is nothing but the ignition of a homogeneous mixture. So I told you the SA engine is going to be homogeneous. The pre-ignition is nothing, again, it's ignition of homogeneous mixture of charge as it comes in contact with the hard surface. In the absence of spark, when you are going to when is going to get in contact with the hard surface. Hard surface is already there. Okay? It's already there in the combustion chamber. In the combustion chamber, where you don't have the spark, assume that the absence of spark, where it doesn't mean that in the absence of spark plug, it means that in the absence of spark, where the spark plug will not discharge electric current. Okay, uh, and again, this pre-ignition is initiated by it can be initiated by overheating the projecting part, such as uh, you need to overheat. You need to overheat the electrode of the spark plug, exhaust valve, metal corners. You can also overheat it. Uh, and again, what happens is about this pre-ignition, when you're overheating the spark plug and the valve, the temperature is going to be remaining high in the surface, which is sufficient to ignite the air fuel itself. And even if you're not if you're not producing the spark, what happens is before it reaches the compression stroke, okay, before the top dips into 20 degree, what we call, uh, spark occurs, and again, this also causes pre-ignition of the charge. Pre-ignition is nothing but the 20 degree before TTC you ignite. That is ignition. What is the meaning of pre-ignition? Pre-ignition is nothing but uh, when you look at the water timing diagram, you can see 20 degree or 15 degree, whatever it is. Okay, so instead of 15 degree or 20 degree, I'm going to have 30 degree, okay, or 35 degree. Okay, I'm going to ignite, which is not a pre-ignition. But the pre-ignition is not going to happen with the help of the spark plug. Yes, spark plug is there already, but spark plug will not induce any electric spark, and because it will not produce any heat during the particular stage. But because of the high temperature, or the temperature is already there in the spark plug electrode, or because of exhaust valve head, when the temperature is already there, that temperature itself is sufficient for the combustion to take place. It means uh, instead of going for ignition stage, it goes for a pre-ignition stage. Okay, where it goes for abnormal thing. Okay, but the abnormal thing will happen only when it comes to particular uh, ignition, where you call uh, it is nothing but the normal stage. Okay, and knocking. What is the this is even I also given you the example of advancing, and this is the ignition. And when you go for a pre-ignition, what happens is, okay, so sometimes this will also lead to the damage core at once also. So similar to that. Okay, and as a result of that, but there is a difference between pre-ignition and knocking. That is where you need to concentrate. So now we'll see what is knocking. Okay, so knocking is due to auto ignition. Uh, you see, there is a difference between pre-ignition, auto ignition, and knocking. So here, in knocking, you are going to get because of the auto ignition of the end portion of the unburned charge in the combustion chamber. So you have the burned position and unburned position, or unburned gases. So this knocking is going to get developed because of the auto ignition of the end portion of the unburned charge. It's going to happen because of the unburned charge. Okay. Uh, it's not going to happen because of the burning. Okay, the unburned charge, what happens is pressure and temperature of the unburned charge will increase, yes, due to the compression by burn portion of the charge. So here, what is important is the auto ignition will happen. It is happening in the knocking gate of thing. So the burned gases will travel with some velocity. There will be some opposition, oppose the there will be the pressure which will happen in a reverse direction will collide. The collision will happen between the unburned gas or unburned charge which is traveling in. For example, if the unburned charge is traveling from top to bottom, there will be similar unburned charge. It will also travel from bottom to top. Both this upward and downward movement will collide each other, and it will create a sound called knocking sound, where you got some tuck noise or some. Maybe you can look at some of the videos in YouTube also how the sound of the knocking will be there. Okay? And that is happening because of the energy between. Because basically it's a pollution. Okay, basically it's pollution that we are going to get. And this pre-ignition will reduce the engine efficiency because you're going to do this with the help of heating the electrode, or and this will also melt. Okay, this will melt the electrode and it will also melt the piston as well. Okay, this will be the impact if you're going for a pre-ignition. It causes holes in the melted piston, and spark plugs also gets melted away because this there will be some hot surface. There will be temperature high in the case of the pre-ignition. And because of that particular temperature, the air and fuel gets the combustion will also take place. It may also lead to the failure of the engine.